This is my final project design called the Horticultural Management System. The system's end goal is to ensure the health of the plant through controlling various environmental conditions. And it does this through two automatic sequences. One, the automatic watering sequence, and two, the automatic grow light, which is at the bottom of the head unit. It also provides user feedback through the IoT hub, which is displayed later on in the other videos. So the system starts off with asking the user to push enter to start. This is the enter button, so it will then ask the user if the internet is enabled. If it is, it will then grab the time from Google, and it will also activate the IoT interface. If it is not, it will grab a time embedded within the software. At the moment it is enabled, so I'll click yes. It will then attempt to connect to the internet and then ask you for a plant type. We have three options: cacti, chives and chili. I'll select cacti. We have three stages: seedling, mature or growth. I will take growth stage, and then it will ask you for a last feed date. I will select an arbitrary date in here, and then it will display the current time and the state of the cacti. And by pressing enter, you can see any active alarms. At the moment there is no active alarm because it takes a while for the system to determine each state. And if pressing up, it will then tell you the last feed date. It has an IoT hub interface which has various displays. First one here is grouped display of humidity, temperature, soil moisture, light, and then below it the various individual parameters shown on the graphs. It also has the alarm states in overview and various command prompts which we'll go through in later videos. And it has a HMS warning section which allows the user to enable email notification, and it will email the user of any issues with the tank or if the plant needs feeding. So this video is to prove the soil moisture sensor is providing feedback to the system and obviously activating the pump when required. So we can see the latest value that's just come in is 36,044 moisture, which is an engineering value, but it's somewhere between dry and moist, so an optimum sort of soil condition. To test this, we need to remove the soil moisture sensor out of the soil, sort of dry off a little bit. So we can see the soil moisture sensor is removed from the soil. And when we look at the reading, it should go up to around about 50,000 engineering value, and it's gone up to 55,454. And there's about 30 seconds for the system to update itself to determine what state it's in, and it shall then activate the pump to water the plant. And we can see water dripping on the cactus. Now this goes into a cycle now, so it will continue watering the soil until it reaches a designated or target set point. So to simulate that the soil reaches the target set point, we shall dip the soil moisture into the water, and it's gone to 19860. You can see that the pump has stopped watering and there is no pump cycle complete reading on the monitor. So this video demonstrates the ability for the user to change or modify the set points within the automatic watering system. So we have a dry set point and a wet set point. These are the triggers for when the pump is stopped and started. So we can see in the dry set point currently it's set at 4 and the wet set point set at 6. So the test figure for this is 5, which will put it at an extreme. So if we change this to 5 and run it, we can then see on the serial monitor that the dry set point has been received and it's set to 5. And we can see that the dry set point has changed to 10,000. Now this will activate the pump because the set point is lower than what the measured value is, and you can see that the pump cycle is complete. Now this will continue to run as long as this set point is lower than the reading initial value, so I will increase that back to number 3, and you can see it's changed to 39,600, which is a lot larger than the measured reading. However, it will continue to pump and cycle because it aims to get this value lower than this value here, so it will continue to pump water into the soil. So to mitigate that, I need to then change this value to the test value of 5, and we'll wait for it to update. And we can see that the wet set point now is 50,000, which is a lot larger than the original, the measured value. And we can see that the pump cycle is now no longer activating. This video shall pass through 1 or 2 of the light states to prove the state machine is working. So you can see currently that we are in partial sun / partial cloud, and if you look outside, it is partially cloudy and a little bit sunny. So, and you can also see the LED matrix is off in this current state. I shall now close the blinds and try and replicate partial shade. So the system is now in partial shade. I've now put the blinds down, and we can see that the system has detected partial shade, and the LED matrix is slightly on. Now another feature with this is I can change the intensity manually. So in partial shade mode on IoT, I can put in a value of 90, which will increase the intensity of the LED matrix. You can see now that the system has detected that I've sent the message 90, and it will update the internal set point. And the internal set point has changed to 90, and the intensity has increased. I've now made it a little bit more darker, and you can see the state has changed to full shade with an LDR reading of 9,302. And we can see that the LED matrix is on. Again, I can change the intensity of this in full shade. I'll change it to 10%. And if we go back to the serial monitor, we can see that the full shade mode is 10, and it will update its internal set point. So see it's changed to 10%, and it is slightly dimmer. So this video tests the LED activation from IoT Hub. And on our first one on our list is the flashing light sequence. This basically runs through a series of colors and then randomly selects an array of colors and remains solid. So if we start this one and run that one, we can see it's running through all the different colors and then randomly selects an array of colors and stays solid. This can be turned off as well, so if you go and run it, we can see that the LED matrix is turned off. So next one is the seedling light, which shall be a blue light. So if we turn that one on, it shall turn on to blue as it is. And then we can prove the brightness alteration. So currently it's at 9. If If I reduce it down to 1, it should be considerably less intensity, and you can see that it is. So, and we'll put that back up to say 5, and we should turn the blue light off and turn on the growth light, which should be a combination of blue and red, and run that one, and you can see the combination of blue and red. And finally we turn that one off and turn on the mature light. This should be a combination of white, red and blue, and look on it, and you can see it's a random combination of white, red and blue lights onto the cactus. This test will test the low level switch in normal mode. So currently I'm running the pump, which is pumping water into the tank, and it is currently at normal level. So I'll continue to run this until I receive the low level alarm. See that there is now a low level alarm. The pump continues to pump out water. The current for it is about 150 to 160 milliamps for the pump, and it's running. I'll continue to pump out until I've got the pump trip status alarm. Now see that the pump trip has now activated. It will update on the IoT shortly. However, you can see that the pump has now stopped pumping. Now it's sent the message to IoT Hub. We should look on there and refresh this page, and you can see that they did. And that's it, and we shall now fill the water back up again and see that the trip status is shall clear. It's been added to the tank. We can see that the alarms have cleared from the serial monitor. The pump is continuing to pump because the soil moisture is outside of the soil, so it's trying to reach that target moisture setting or level. If we go onto the IoT Hub, we can now see that the trip status and water level have now cleared. This video proves the email notification feature. So any alarm for the top 3, so I'll generate an email to the user prompting them to take action. So you can see that this is the email that was received. It details that the HMS warning is true, pump trip alarm is true, feed required is true, and low level alarm is true. Now to get rid of the feed required status, you need to go to commands and scroll down to the update feed button and press true and run that. And what it'll do is it'll generate a message on the monitor to say that the updated feed was today's date, which is today's date of the 5th of the 5th. And if we go to the local interface and press the button, we can see that the feed date is the 5th of the 5th, 2022.